Determine if R is significant. Critical value method. So I'm going to just demonstrate the method of determining the significance of the correlation coefficient R. So in number one, suppose that R, our correlation, is 0.654 and n equals 12. We're going to determine if R is significant or not using our critical value table. Now, before we go to the table, first let's review the steps. So here's our steps. First, we will find the degrees of freedom. The degrees of freedom is n minus 2. Okay, now it's n minus 2 because when we're dealing with correlation, it comes from a data table with x and y, and you have a bunch of these. So we're subtracting by 2 when we're dealing with linear regression. That's where our correlation comes from. So in this example, n was 12, so the degrees of freedom would be 12 minus 2 gives you 10. So it's as simple as that. Just remember, from linear regression, we had an x and y independent and dependent variable, so we'll take n minus 2. Now we'll go to the next step, find the critical value from the table, and then we'll compare it to R. So I'm going to show the table. It's right down here. Here's my table. And I have a degrees of freedom of 10. So I'm going to read off this critical value. Now the critical value tells us that there's a plus and minus. So really this 0.576 is really negative 0.576 and positive 0.576. That's how you read the table. You go to the degrees of freedom, read off the critical value. We found our critical value to be 0.576. Now with the critical value, we really need to think about plus and minus. So I am going to build a number line, and this is where it comes into the comparison idea. So now we are going to compare to R. So the critical value, we're going to compare to R. Now if R is between the positive and negative critical value, then the correlation is not significant, and we should not use the line for prediction. Now if R is not between the positive and negative critical values, then we can trust the validity of the best fit line. So this is why I'm making a number line. I'll show you this here. Let's mark negative 0.576 here and positive 0.576 here. You can imagine that 0 is in between there. Now we know that correlation values R is always going to be between negative 1 and 1. Okay, R is always between 1 and negative 1. So you can imagine that 1 and negative 1 is somewhere out here in the world. And let's mark where our value of R actually is. So our R value is somewhere over here because R is 0.654. It is greater than 0.576. So it's a little bit to the right. Okay, so I'll mark it there. Now let's think about what our rules state with these two bullet points here. If R is between, not significant. So I will label right here, this is the not significant region, right? From here to here, this is the not significant area. But if it's on the outside, here, this is the significant region, right? It's significant here, and it's also significant here. So the decision we can make is that yes, it is significant because our R value is not between the positive and negative critical values. Now there is some theory behind this, but I am just demonstrating the method for us. Okay, so let's do this on a different example. So suppose that R equals negative 0.82 and n equals 16. Determine if R is significant or not using the critical values table. So first things first, we need to find the degrees of freedom. And we can remember the formula is n minus 2. And we have 16 minus 2, so we have a degrees of freedom of 14. 14 degrees of freedom, I'm going to go to the table, and I can see degrees of freedom, read off 14. So my critical value my critical value is plus minus 0.497. Plus or minus because we have to check either whether you're between or outside of. So now I'm going to build a number line. Mark the number line. Okay, negative 0.497, positive 0.497. Okay, now we know that if you land in the in-between, it's not significant. And if you're out here, it is significant. So I will label that significant, significant. So now let's go to our R value. R is negative 0.82. Negative 0.82, I will mark that. It's actually way out here. Negative 0.82 is actually pretty close to negative 1, right? It's way out there. Positive 1 is way out here. So we are in the significant region. So yes, we are happy. We could use the line for making predictions. It is a validly made line. Now, we don't see the equation of the line, but the equation of the line would be in this form, and it would have came from a different step. But right now, we're just determining if that correlation is valid. Number 3. Suppose that R equals negative 0.472 and N is 11. Determine if R is significant or not. So the degrees of freedom is always your first step. We will do 11 minus 2 because our formula is always N minus 2. So we would get 9. So let's now look on our table for 9. So degrees of freedom, 9. Our critical value will be plus minus 0.602. And now that we have that, we will draw the number line. So we'll draw a number line. Okay, negative 0.602 and positive 0.602. And then we know if it's in the in-between, it's not significant. And then if it's out here, it is significant. And I will just abbreviate now. I don't want to write out significant every single time. So is significant, I've abbreviated. Now I will label where R equals negative 0.472. Okay, negative 1's out here, positive 1's out here. 0's right here, so negative 0.472 would be somewhere in here. Now look, I have fallen in the in-between. And when you're in the in-between, this is not significant. So it's not significant using our critical value table. So if the correlation value is not significant, the correlation value tells us that the strength is weak. We have a weak line, a weak relationship made here. So we will not use that line that is created for prediction. Let's do another one. Number 4, suppose that R equals 0.384 and N equals 25. Determine if R is significant or not. So first things first, degrees of freedom, N minus 2. Well, we know that's 25 minus 2, which gives you 23. And then we look at 23 and degrees of freedom on our table. So 23 is right here. We can see that matches up. So then our critical value would be plus minus 0.396. 0.396. And using our method, we will create a number line. We will mark the number line, negative 396 here, positive 0.396 goes here. Now I know positive 1 and negative 1 is out here. You don't have to draw that if you don't want to. I know 0 is right here. You don't have to draw that as well. Because all that we're interested in is if we're in the in-between or not in the in-between. So here I'm looking at R equals 0.384. Now this would be right about here. R equals 0.384. It's not quite to 396. Okay, it's not quite there. And since it's not quite there, we do fall on the in-between here. It is in the in-between. So this is where we determine that it's not significant. So it's not significant because it's in the in-between. So we would not be able to use that best fit line created. Continuing on, let's do one more good example. So suppose that r equals -0.443 and n equals 52. Determine if r is significant. So the degrees of freedom is n minus 2. So 52 minus 2 gives you 50. So the degrees of freedom is 50. Let's find where that is on the table. So I'm going to be looking for the degrees of freedom, 50. So here we go. So then our critical value would be plus or minus 0.273. And then now that we have that, we will be drawing our number line, -0.273 and +0.273. And we know that +1, -1 is way out here, zeros right in the middle. Okay, our R value, our correlation is -0.443. -0.443 is right here. So this is on the outer region, right? Because in the in-between, this is the not location, not significant. But this right here, it is significant. It is significant. So we're happy. R is significant. We are done there. Okay, thank you for watching.